last class we discussed about the inverse of cos function. Today we discuss about the inverse of tan function. The tan function is already known. The domain of the tan function is R real number except 2n plus 1 pi by 2 or Rn belongs to the real number. Okay, range of the tan function is real number. Okay, here it is a diagrammatical representation of tan function. Tan function is R except 2n plus 1 pi by 2. It is a real number in a codomain. Next here it is tan 0 is 0, tan pi by 2 is infinity, tan pi by 4 is 1. Okay, similar tan 3 pi by 2 is infinity. Here it is two domain images of the same codomain image. That is the same codomain image. Hence, the function is not a one-one function. Hence, it is not a bijective function. Not a bijective function means inverse does not exist for this function. That's why if you restricted the domain into minus pi by 2 to plus pi by 2, closed interval, not a closed interval, it is an open interval. That is a minus pi by 2 to plus pi by 2, then the arrow diagrammatical representation here. That is minus pi by 2 to plus pi by 2, real number range as it is or codomain as it is. Next, minus pi by 2. Tan of minus pi by 2 is minus 1. Okay, tan of 0 is 0. Tan pi by 4 is 1. Okay, tan pi by 3 is root 3 by 2. Means different elements have domain of the different images in codomain. Hence, the function is holds for both 1, 1 as well as on 2. Hence, the function has the inverse, that is tan inverse exists for this domain, that is minus pi by 2 to plus pi by 2 open interval. Okay, I have rewritten the tan function in the form of restriction of domain. That is the domain of the tan function is restricted to minus pi by 2 to plus pi by 2 real number. Next here it is again diagrammatical representation, that is the tan of minus pi by 4 is minus 1, tan of 0 is 0, tan of pi by 4 is 1. This is bijective function, hence inverse exists. Inverse of this function is domain to codomain becomes codomain to domain. That is real number, that is codomain of tan function is domain of the tan inverse function. That is R, that is the codomain of the tan function. Tan function becomes domain of the tan function, tan inverse function. Then domain of the tan function becomes codomain of the tan inverse function. That is minus pi by 2 to plus pi by 2. That is tan inverse of minus 1 is minus pi by 4. Tan inverse of 0 is 0. Tan inverse of 1 is pi by 4. Okay, in similar manner, other three trigonometric functions also has the inverses. Both holds for bijective condition according to the restriction of the domains. That is the domain of tan inverse function is R and range of the tan inverse function is minus pi by 2 to plus pi by 2 in open interval. Okay, range of this tan inverse function is also called principal value range of the inverse trigonometric functions. Okay. Here is a graphical representation of tan function as well as inverse function. That is tan yx equal to tan y. The value of tan 0 is 0, tan pi by 2 is infinity. Not touched for this function. That is not touched to pi by 2. Tan pi by 2 is what? It is infinity, plus infinity. Next here this tan minus pi by 2 is minus infinity. The graph of tan function is first year class. Okay, then in second year class there is tan inverse x function. That is the graph of tan inverse function is just changing the axis. That is x-axis becomes y-axis and y-axis becomes x-axis. That is y-axis has the values minus pi by 2 plus pi by 2, then pi and minus pi. That is tan inverse of 0 is 0, tan inverse of minus pi by 2 is minus infinity, tan inverse of plus pi by 2 is plus infinity, tan inverse of minus pi by 2 is minus infinity. Okay, these are the graphical notation of inverse trigonometric function, that is a tan